let's learn how to build some awesome apps.
Yes, some awesome Azure function apps.
Exactly.
So, as said, I'm Rachel. I work at JetBrains as a developer advocate, and this is what I do. I give talks and write blog posts and make content and write code and all that good nerdy stuff. So for now, let's talk about building Azure function apps and a nice introduction to them, what they are, what they can do for you, a little bit of how to work with them, and what the code would look like if you come from another aspect of .NET development. Or even if you don't, because Azure Functions work with a lot of other languages that aren't Microsoft languages as well. So what is Azure Functions? This is they're not new anymore. They've been around for a little while now. And it is basically taking a function, which is your most basic unit of code, and putting it in the cloud and running it. And there's a little more to it than that, but you can take this function and soup it up and connect it to other resources in the cloud, which is what really makes it cool. Amazon has a competing product as well called Lambdas. So if somebody's done Lambdas, it's conceptually the same. Right? So it's this way to have little bits of code. And these work in a wide variety of scenarios. So there's a lot of really good things you can do with functions. And the cool thing is if you're already writing .NET apps, it doesn't matter if they're ASP.NET or WPF or Xamarin stuff, it doesn't matter. You don't have to throw all your stuff out and move over to functions. You can actually integrate functions here and there. They're perfect for this. Integrate them into some of your existing code bases for those little scenarios that just don't quite fit in or that are kind of a pain to work with in your traditional development scenarios. So the premise of an Azure function is that we take code and events with data and you smash them together, and they just wanted a really cool animated icon, and that's how they did it. That's cool. I like lightning bolt. That's good. And that makes Azure function. So it's code plus events and data, which actually sounds a lot like a regular function as well. It's code. You have some data in the form of inputs and outputs, and the events are when something would call on that function. So the same kind of concept, but we're going to cloudify it this time. So it's our unit of work, the same as a regular old function in code. It's a thing that executes. There's a start to it, a clear start, a clear finish, inputs and outputs. Kind of nothing new here to see as far as that concept is concerned. It is when we put it in the cloud and start connecting things to it that it becomes really, really great. And the cool thing is it's not a whole lot of brand new knowledge or anything that you really need to do this. It is just standard .NET code with a few bits of scaffolding around it. So yeah, this is pretty familiar, right? So we could take our just very, very core programming knowledge and shove that in the cloud and make some really great things with it. So some use cases. We have this in every company. Every company I've ever worked at, consulted at, or even blinked at has a timer-based app that does some batch processing. Or maybe it's once a week or once a month for payroll, or customer leads for sales, that it just waits for a timer to happen and then some code runs. And this code is often code like that to put it in a Visual Studio solution and then deploy it somewhere and then have to maybe set up AT commands or some little script to go and pull for the time and then run it. It's a little bit of clunky work that often happens. But we can take something like this, just throw it in the cloud and tell the cloud, like, you bother with the timing and run it when you're supposed to. And it's all in one location. It's quite nice. Another one would be like Excel to something, right? Excel to SQL, Excel. Users in their Excel, right? They love it. And then it becomes the bane of the developer's existence. You have to integrate things with Excel. Well, there's actually a lot of nice things you can do to integrate with Excel. We also have webhooks, so you can do things like create an ad based on a profile, because it seems if you're working on the web now, ads are the thing you do, right? But yeah, webhooks to create things. Async image processing, map processing, all kind of data processing, stream processing, bot messaging, not just CRM, but any kind of systems integration. Integration is a really nice sweet spot for functions as well. Those are just some of the things that you might consider using them for. Some real world scenarios of customers that I've seen. A lot of the carriers that do shipping, they have package and vehicle tracking, and every time they scan a package, it just sends a little HTTP request to an Azure function, which then kicks off an entire workflow, and that ends up with that little piece of data somewhere in a database, and you get that instantaneous tracking. You can even integrate this with SignalR to make it instantaneous, so that I've noticed this when packages come and they scan it, within moments, I get a little notification on my phone. So, you know, they're doing something like that. It could be with Azure or something else that has real-time libraries, but that's really cool that they can do stuff like that. Data cleanup, ETL. Yeah, we got to do that all the time. It's a pain in the butt because somebody out there, you know, did not make the database exactly correctly, maybe the way they should, or it wasn't, you know, maybe it was at the time, but things evolved, and, you know, sometimes you have to run batch processing to clean up some of your databases, especially relational databases. Things like document databases and graphs are not quite the same, but on relational stuff, and there's still a lot of it out there, we do have to do a lot of that. Or batch processing of Excel again, or text files, just pulling in text files or JSON or XML and sucking those right into SQL, stuff like that. That's a really good scenario for this kind of thing, right? So you can actually, you know, send stuff to a function and then process it that way. So all kind of batch processing and just working with data and integrating between different systems. As far as IoT, Washington, DC had a snow depth monitor IoT solution going, where they put down little sensors to see how heavy the snow was and the amount of traffic that would run over, like a little sensor that looked like a rope that goes across the road, and that would send a little notification to a little HTTP request off to a function, and they could check and see the stats in real time. Some football teams, the American sports ball, has equipment monitor, because they actually need to pad themselves up to get, you know, they're already getting brain damage and they don't want to get more brain damage. So they put on the helmets and all the padding, and they actually have sensors in there to see exactly how much brain damage they're going to get when they smash into each other. I don't understand this sport at all, because I don't like brain damage, but there's an IoT solution for monitoring that, and they used Azure functions in some football teams to do this. Also, internet traffic. So there was traffic, car traffic, and vehicle traffic, but also internet traffic. A client in the UK was doing internet, basically your company, if they monitor your internet connectivity, they plugged in some functions that every time it would register a piece of internet activity, it would send off a function. And they were talking about millions and millions of hits every day from large Fortune 500 companies. And functions were just processing it, and gathering all that data, putting it into massive data warehouses, and then they were able to report on that and see exactly how employees are spending their time. So there was a client that actually builds internet traffic reporting systems, and other clients of theirs who buy them, and Azure Functions was all the way through all of this. So there's a few real world scenarios, and a lot of these are very high volume processing. Now, it doesn't have to be high volume, But if it is, if you are doing high volume stuff, this is really a good way to go. And it's pretty cheap compared to other solutions. We'll come back to the pricing and cheapness of things. But for now, we'll start off with open source, of course. Microsoft's all about the open source now. So you just go to GitHub and look at the code. And if you go to af-start, this little bit.ly, gives you a little bit more information on Azure Functions and its open sourceness and where to get started with it. So Azure Functions are part of this thing called Serverless Computing. And I'm pretty sure by this time in history, nobody is fooled anymore. Was anybody ever fooled? There is no such thing as actual serverless computing. There is a server. It's just not a server that you care about. Right? You don't have to have an admin for it. The server is not physically yours. It's somebody else's server. And you just put all your stuff over there and you sign a service agreement with them and they keep things up and running and nice and smoothly working for you. So there is a server, it's just not yours. So that's what we call serverless, which is all about running code instead of computers. Because if you've worked in a corporate environment for any amount of time, you realize that the IT people are there and they're a great help. They keep the servers up, they keep them running, but it is a lot of costs, a lot of maintenance. You have to buy more equipment, and depending on how programs are written, sometimes they have to end up throwing more hardware at the problem to fix things, and sometimes they don't like it, and sometimes there's some issues between development staff and sysadmins. That also happens. You get a little bit of friction. So you can't just write code. You have to work with IT people, and you have to work with the people maintaining your systems. Now, this is great in corporate environments where you do own all your own equipment and you might have agreements with hardware folks. But if you're a small company, you might not be able to afford a programmer and IT people. Right? So you might not have enough for a whole staff, right? Or if you're a startup. So that's where the cloud also comes in handy. It does come in handy in the enterprise scenario as well, because you can offload some of the job and issues of IT to the cloud. But in a smaller company, you could just have this small little share of the cloud for yourself that you just pay for what you use, and that's that. And you don't have to worry about having to hire full-time staff for it. And then this way, the programmer can focus on just the code as opposed to the code and the infrastructure as well, which is what developers really want to do. We don't want to have to deal with the IT stuff, or we would be admins, but we're not. So yeah, there's a server, it's not yours. Now for serverless computing and functions in particular, really great for stateless stuff, although as would be expected, Azure Functions came out and the folks who made them said, these are meant to be stateless. You know, the internet's stateless and this is how it's supposed to be. And then people started using them and said, yeah, but we want some state. Can we have state? Can we have state now, please? Can we have state? So now we have this thing called durable functions, which helps you get around some of the issues with statelessness. For serverless computing, this is kind of interesting. It works well with complex architectures, but it also works well with very simple architectures. So if you have this like really crazy microservice architecture, serverless computing, stuff like functions is a great way to orchestrate this. But also, if you flip the coin and you look at just one tiny little job that needs to run, and that job is only 10 lines of code to maybe copy a file somewhere and just put that data in a tiny table somewhere. That also is perfect for an Azure function, as opposed to taking that piece of code and sticking it on a machine somewhere and then forgetting where it is. I've actually seen that happen multiple times. People would make small utilities that run on a timer and they would put it on a server and then forget where they deployed it to, because you have 20 or 30 servers, and then there it is. Like, or where is it really? Not there it is. They can't find it. So things like that happen. Or can't tell you how many places I worked at that had a dedicated computer. It'd be this little computer, not necessarily a server, and it's always over in a dark corner of one of the team rooms. And it just sits there and people don't touch it, and people are somewhat scared of it, like it's haunted or something. And when you figure out what's going on over there, is there's usually one or a few programs that are just dedicated to running, usually again on a timer, but sometimes with some other logic behind it. And they just sit there and run all day. So it's not a workstation that people work on, it just runs some automatic processes, and they're automatic because there's some scripts set up to check the time and run out a timer. The problem is people tend to forget what the passwords are on these machines, or whose account it's even supposed to be run under. And there's all kinds of problems with it, right? If somebody who knows about this machine gets hit by a bus, then nobody knows what's going on there. And if something breaks, you're in big trouble because data might not get moved or integrated between databases or whatever needs to happen. And sometimes it is actual mission critical work on this weird little machine just sitting in the corner that nobody likes to touch. And I've seen this so many times, it's just amazing that hardware manufacturers haven't gotten in on this to actually sell machines targeted for this, but too late now because we have the cloud. So instead of having it on that machine, you could have it in the cloud. So somebody could forget about it over there instead. Really though, if you have a cloud account, some management should have some nice rules in place where multiple people can access that and you're not going to lose that data. So the serverless computing, again, complex architectures or the small architectures, or to get rid of those kind of issues, that little machine in the corner. The sporadic workloads. We're at a conference, so you have conferences that happen once a year, and maybe they sell tickets starting 3 months before the conference. So this software might only be in use for 3 months out of the year. Well, for 9 months, I do not want to pay for a server, pay to have to security patch it, have the IT person run it, deal with it, have anything that breaks on it, like anything that comes with that, like all that maintenance, and having to do that for a piece of software that's not even running is a little bit wasteful. So I would rather just put that in the cloud. So sporadic workloads is great. You can just have your code in the cloud turned off, just stopped. And when you need it, you just spin it up, let it run for as long as it needs. You only pay for that amount, and then you're done at the end. So it's perfect for things like that. And there's a lot of software that does that. Tax time, that happens with software. And a lot of software spins up, runs for a short time, and then it's done. Stuff that performs an action over CRUD, right? So, all this stuff is integrating, moving data, batch processing, or complex architectures, workflows, workloads, which is much more than just data in and data out. That's a standard or traditional application, usually with an API. So that's where you might consider an API if you're going to stay with that classic kind of, CRUD type of model, as opposed to something that's going to just do stuff and perform actions and not necessarily grab data and show it to the user. And all this, of course, is event driven. So you'll see an event has to start every function, and that event is called a trigger. So I already mentioned some of these in the last slides, but yeah, simple or complicated stuff that's on the outskirts of a traditional app. Stateless is better. Low human involvement is another good one. So you just stick it in the cloud and you're good. Lots of services involved, or hardly any. And integration is a biggie too. Integration is really nice when you have this central location, an easy way to glue systems and services together. So the architecture, here's your obligatory Microsoft style architecture slide. So down at the bottom is all the runtime. And there's a .NET runtime, but because there's actually more languages than are shown on this slide up in the language runtime, you'll see there's Java, Python, others as well. But way down at the bottom, you have the actual, Azure runtimes, hosting, deployment slots, debugging. On top of that, the web jobs and core and extensions. Before they were functions, they were called web jobs, and it was like the precursor to functions. So you'll see the word web jobs scattered about in some of the namespaces, and a little bit of that left over. So things like we're really going to work in this level a lot, the triggers, input and output bindings as well. And of course, the programming model itself and common abstractions. Above that, you have the script and language runtimes. So things like the functions host itself, being able to write in C# or JavaScript or Python or whatever. And then above that is just your own code and config. So we have some various levels of how the architecture works on an Azure Functions box in the cloud. For us, mostly we just need to worry about the code, right? And unless we have some really weird things going on. So with that is moving from monolith into this new paradigm and new architecture level. And we had these terrible, really big, just crap code, right? This happens, right? You have these big systems, the big monoliths. It's really hard to deal with them because everything's tightly coupled and crammed together, and often in one solution that might have, dozens of projects and stuff all over. What we want to do is possibly break that up into a microservice style architecture. It doesn't have to be actual microservices. You might just be able to take certain parts of a very complex application and move them out to the cloud, the ones that are giving you the most problem, and split those up. Of course, what happens often is people have a monolith that has evolved over time, and it becomes hard to maintain. Often they just kind of just start moving that and trying to replicate that same thing on the cloud, and then they just end up with, microservices, little crap microservices. So we don't want to do that. What you want to do is think about how you might architect it first. If you're going for a true microservice architecture, there are entire conferences on that. So you can sit for 40 whole hours just listening to ways to architect microservices. But one of the great ways to get into serverless and Azure Functions is just take a little piece out. It's easier to shovel the little bits than it is the big one. And take little pieces out where you can decouple them from your app if they are pieces like integration pieces or small utilities and things like that, and you can move them into a function. If you have to move an entire monolith to a full microservice architecture, you have a really big project, but you can do that, and you can do that with functions. Here's a slide that shows what it might look like to have a complex app with functions, and this isn't even all that complex compared to some. Perhaps somebody makes an HTTP post, and that triggers off an Azure function, which then plops some data in a Cosmos DB. But also it takes that data and sends it over to an event hub, which then, once that happens, I can say anytime a piece of data hits this event hub, have analytics run, right? And then after analytics run, I can have another event hub automatically pick that up again. And then maybe that triggers another function, which then sends an email to say that we're done. But the point of this slide is you can see you can mix and match things. You can have Azure functions that connect things like Cosmos DB and Event Hub. And outside of Azure functions, you could connect these other Azure services like Event Hub and Analytics and other things. And Azure function they also integrate with non-Microsoft products as well, like Twilio, SMS and email, and things like that. So that's very nice that we can do that. So if you had to register for an email or something like that, people can sign up. You can use an Azure function then to send a Twilio email or SMS to them. Of course, it doesn't help you with GDPR. You have to figure that out for yourself. But you can do it technically here with Azure functions. And Azure functions might be interspersed within a workflow or even, this first part here with an HTTP host and an Azure function. Well, I might have that integrated with a standard application that sends a piece of data to an Azure function, and it runs off and does a few things outside of the application, where I was trying to incorporate that before into my solution, and it might have been a bit hard to maintain, and the code might have been coupled a bit much. So for programming, we'll take a look at the programming model now, which was getting up into the top part of the architecture. So we have, for every single function, we can have a function in a function app. The function app itself is a shell, kind of like a solution or project, loosely. And that function, Azure function app, can have one or more functions in it, which is kind of like any other .NET project, or actually more like at the class level, right? Any .NET class, like a C# class, can have multiple functions in it. But with top level functions, you can actually have a top level function, but let's just stick with the class level here. So every class can have multiple functions in it. So you could kind of think of it as that level. So you have this shell or this Azure function app, and it has a function in it, one or more. So we'll just stick with one app and one function for now. That function, or any function and every function, has a trigger. And this trigger is the event that starts it. You have to have some way to kick off the code. So one trigger and only one trigger. Then we can add one or more inputs. Now this is just like a regular function in programming. You can have a whole bunch of arguments or parameters passed into a function. So it's the same thing here. So you can have one or more inputs. And then you have some code and possibly configuration. And then you have some outputs. Right? And you could have, unlike the .NET model, some languages support this, but unlike C#, unless you use an out variable, you can have multiple outputs. So I can have multiple inputs and multiple outputs. So the output can be a Cosmos DB database as well as Event Hub. So I could send this data. Instead of thinking of it as an output per se, you might think of it as sending this data or binding this data to these other resources, which might be Cosmos DB or something else. And the same thing for the input. We call them inputs and outputs, but we also call them bindings. So we might bind from resources. That resource might be an HTTP endpoint, or maybe whenever an item is dropped on a queue or in Cosmos DB, that will trigger the function. So there's many things that could trigger it. And then we run our code, and then we can produce the output or the bindings to other resources. The code is just standard .NET code. You can obviously use Java, Python, and some others as well, but I'm keeping it in C# here to be simple. But your code and configurations all JSON. So here's some of these supported bindings and trigger. I made a bit.ly here, so you can go to bit.ly AF bindings. They do update this once in a while, but as you can see, there's these different types, and really the big ones are, you get your versions here, but over here, the three on the right, almost all of these are a trigger, right? So I can have blob storage. So whenever some blob gets put into storage, that could cause a trigger to run, or that could cause a function to run. Whenever something comes in via HTTP, that could cause it to run. Whenever something gets put onto a queue, that could cause it to run. So all of these with the check here are triggers that can cause a function to run. Then we have inputs and outputs. And for the inputs and outputs, some of these can be inputs, but things like HTTP, for example, is not a good input. It is a good way to kick off a function, but we'll see that you can get some input from the endpoint, but generally we might actually use something else for input as well. Or here, mobile apps could be input, but generally you wouldn't trigger from the mobile apps services in Azure. So here's some other ones, like a timer. A timer would trigger a function, That's exactly its use, but it's not useful for input or output. How would you input a trigger or output it? You already know what time you need it to run or how many minutes apart or whatever. So some of these, and these are all called bindings, right? A trigger is a binding, but it's the one that kicks off the function. So you have all these different ways to kick off a function, and you have these different supported inputs and different supported outputs. And if you go to that link again, you'll see there's probably an updated slide. I haven't checked on this one in a while, but it'll give you a nice grid of exactly anything that's been added or not. Some of these make sense as well, like Twilio, like an email or SMS. You would not have an SMS input. You can have it for an output. Right? So from SMS or from a phone, you can have an HTTP endpoint that can get some data. So let's take a look at some code here. I'm going to show two ways to do this with the code. One is I'm going to go into the portal so we can see the mechanics of how it works. And then I'm going to show you in Rider. So it doesn't matter what editor or IDE you use. Being that I'm JetBrains, I'm going to use Rider because that's our IDE. But here, as you see, once you've logged into Azure, I can go to Function Apps. And then here, you'll see your list of function apps. I can say I want to create a new function app. And here it's going to ask me things, the things that you need to know, whether you use the IDE or the portal. What subscription? So I already have a subscription set. A resource group. Resource groups are just ways to virtually bundle resources together for management. So that's entirely up to you. It doesn't affect costs or performance or anything like that. So I'll just call it new function app and hope that this is not taken. So that's also something you do have to have a nice unique name, as you might expect. Of course. So we'll do what any developer does. I'll add 1, 2, 3 after that. Right? Or like test new function app. That's what we all do. Here you can do code Docker container, so it's Dockerized already. And here's where you get to pick your runtime stack. So you can go on to Java or Python, and your version and region. So for the region, I'll pick something close. And I can just tell it, go ahead and create it now, or I could go on and see what other options are available. Yeah, sure. So here I'll take a storage account that I already have, and the operating system, so you can pick that as well, and the plan type. Now here's something you want to note. Most likely you want to stay on this plan called consumption serverless. If you pick premium, that sounds expensive because it is, and app service plan is like a set fixed amount. So if you only use a small fraction of those resources, you're still paying for that set amount. And if you go over, you get overage charges or shut off until you pay. So we don't want that. Consumption is paying only when you need it for Azure functions. And there's a little link that gives you all of the details here. So you could pick out something that works. So that's a good thing about functions, that you only pay when they're running, which also means, pro tip, don't write crappy code, because if you write code with tons of loops and that eats up all kind of resources and dillies and dallies and takes its time, and there's always that person on the team, you know who it is. If you're letting them put code in the cloud here in Azure Functions, and that code is just looping away and very slow, then it's literally going to cost you money. So consider how to optimize. So things like use your string builder to make it faster, and any kind of performance ops that you could use, and keeping them small. Right? So functions aren't supposed to be these giant gross things. They are single functions, and you can have many of them so that one runs quickly, the next one runs quickly, the next one runs quickly, and we can pass data to resources, off to resources between the calls, so that we're not tying up one large chunk of time. So I'll go ahead and I'll go to monitoring. I don't want it for a sample, but you can have all kind of fancy monitoring with App Insights. And you can do tags and cool stuff like that. I'll go ahead and create, and you wait a little while it goes off and does its thing. And so I'll click create. And it'll give me this little deployment in progress for a bit. While it's doing that, I will hop over to Rider and show you the similar way of doing it in any IDE. So in any IDE, you would do a new project or a new solution. That IDE would need to support Azure functions, and Rider does, and Visual Studio does, and I think there's a plugin for code as well. So they all do. And then I can have my function app name. And again, I would have to pick a nice unique name. My unique function app, that's probably taken. Let's do 1, 2, 3 again. So my unique function app 1, 2, 3. And then from here, I could pick the language and things like that. Now, Rider doesn't support Python or other things like that. We're just .NET. JetBrains does have IDEs for those other languages. It's just not Rider. Now, the actual programming model is very simple. So you're not going to see a whole lot of files in here. And we're going to actually see how the solution and project kind of are only necessary for the usage of an IDE. So you see here, nothing in here. It's a nice empty function app. All I have is a couple of JSON files, local settings and a host JSON. And you'll use these JSON files to configure your function app. Once I have this up and running, I can then start adding some function app code to it. But what I'll do is I'll pop back into here, into the portal, so we can dig around in the function a little bit more first. Then we'll come back into Rider and match it up and see how it would work in our IDE. Because there's going to be a lot more in the portal as far as management goes than you will see in any IDE right now. So right now, I could do all of this stuff: browsing, stop, start, refresh, delete. A couple things you might want to do. This publish profile gives you credentials for like FTP or other type of deployments. So you can download this, and it does have password in it and whatnot. So just note that. And you could actually use that to integrate with your tools to deploy if you want. But here, since I have this nice new shiny function app, this is that whole blank app, no functions in it yet. But you'll see I could check the activity along the left here: access control, tags, security, events. So I get some of the overview activity for managing it. And then here's the good part: functions. And in here, my actual files, keys, and proxies. I'll come back to this part in just a minute. If I go down a little further, I can have deployments. So you can actually do these cool deployment slots in Azure. So if I deploy version 1, and that's up and running, and I want to deploy version 1.2, I can actually put that in a staging and test it out. While it's staging, I could go from like dev to staging to production, and each of these are a slot. And say I'm in staging, and I say, hey, this is great. The testers think this is ready to go. I can then swap that with the production and then just make it go over to production right away. And it's a really nice, smooth way to do things. Also, there is configuration. So you see a lot of JSON in here, and a lot of these are all like saved behind the scenes with JSON. But here I see connections to all the Azure assets that I work with. So anytime I make anything in Azure, you'll see some of the storage, Azure storage being used to keep your configuration and other settings. Might not be a lot of storage, but it is some storage. Also, as you might expect, authentication, authorization, and there's your application insights for your monitoring, a little bit more of security, identity, custom domains. Right, so you get all of these cool things. If I come down to properties, I will also see some goodie stuff in here. My URL, IP addresses, and some FTP information. I know it's old school, but I really like deploying via FTP. I've done it for so long that it's so easy to do, right? Or FTPS even, right? So they give you the host names and all this stuff. You can actually go in and change with the publish profile and change the password for the FTP user as well. So, but here it shows you all of that. It's really nice and easy if you just want to pop one file out there. Some tools. So here's some other tools that I'm going to show you in a minute. You might want to look at this console and this app service editor. So this is like VS Code, but in the cloud. And it's actually what VS Code was before it was a desktop product, which is kind of interesting. And also these extensions, these are going to be a bit important. As you go through and you want to add functionality, and you maybe want like EF Core or some other cool, like basically what would be a NuGet package, you could come in here and add them as adding an extension. Additionally, if you wanted to make an API out of this, functions are not the best for an API, but if you wanted to, you can. Also cores and logs, right? So you can get like the full breadth of management here. If I come back up and take a look at functions, and I just click in here, I don't have it. So I'll quickly add one. So when I do an add a function, it's going to ask me like, oh, how do you want to do this? So I could say like VS Code or any editor, which literally these are almost the same here. And these actually will give me NPM to make sure if you're going to do this with the tools, an editor or an IDE, they'll have the core tools installed, or they should. But then you can actually use command line, like this func new, func init, or also the Azure CLI, and you'll see AZ login, AZ function create. There's a whole bunch of these commands that you can use, either with the word func or AZ as what you're going to use to start these. So here it's kind of like the .NET new, .NET run, but for Azure functions, and then also deployment. So if you want to do that with any old notepad, even knock yourself out, you can. Or here I could just say, I'll develop in the portal, which is not the best editor at all, but it's nice to see how this connects with the code first before we run off writing code in an editor. So here's these different templates I get for those triggers, right? So all those different triggers that I can have, everything, even RabbitMQ, I believe that didn't even make it to the slide. That's a little bit newer, right? Durable functions, SendGrid, all of that good stuff. So I'll just grab an HTTP trigger. And if I scroll down a little, it just asks me what I want to call it. So maybe I'll just call it the add to queue. That's a nice little sample I have. And I'm not going to deal with authorization right now, but as you see, I can just put this right in my function right away. So I'll let this anonymous, and I'll click add, and it takes it a second or two, and then I'll actually see code here in the portal that I can modify. And here's where the bindings trigger plus the code inputs and outputs all kind of comes into play. So now I still have my function app, and then I have this add to queue function and a few details about it. If I come here and I click on this code plus test, it might take it a minute to spin up here. I will actually see some code. So what this does is it actually just comes through and accepts an HTTP request, does a little bit of logging, and then prints out a response message with a 200 OK result. So it's a quick in and out. So this is a very easy one. And this code could be anything. They just give you a little bit of template code here, but this can actually just really quickly stick some data into a Azure SQL database using Entity Framework, or I could pop something onto a queue. I could send an email via Twilio, SMS, like any of this good stuff. What I'll do for now is I'll just click on this get function URL. So each function, as well as the app, gets its own URL. So I'll copy that to the clipboard, and I'll bring up a nice new tab. And I'll click this add to, here it goes right to the add to queue, and it does like the API style URL. And it says, yes. So this was triggered, but please pass in the name of a query string, right? So if I take a look, that's this here, because I did not put a name on it, and it's looking for a query string called name. So, okay, I'll go back and do that. And I'll just put in name Joe. And you see the message has changed. And yeah, so you can see it actually did print out this part, right, of this ternary operator. So yeah, this looks good. Right, so I have a nice little HTTP endpoint, so I could send this piece of data in, and here I've collected it and then just spit it back out. So what I might do with this to hook this up to other parts of my system, if I go to this integration tab, here you can see those points kind of put together. I could see that is my HTTP request, and if I click on it, I get these bindings again. And here's the name. So if I go look in the code, in the arguments, the parameters as they're set up in the function, it's called REQ. But I can also put in a route template, and there's that anonymous that I picked, and I can also select whatever HTTP methods I want. So if I go back to the code plus test, always takes it too long to refresh. If you take a look, yep, there it was called request. You also get an iLogger everywhere for free. Like everything has an iLogger for free. So you can just log, it's injected for us. So we get to use that. Now if I go back to integration, then I see function. If I click here, that just takes me back to the code. So there's my trigger, any inputs. Because the HTTP request does accept GET, I don't necessarily have to have an input, but I can. If I click add input, I could pick any of these cool things, right? And if I add more extensions, there's even more that I can add, but this is just the basic stuff. So I could take these inputs. Oh, I accidentally clicked far, far away. Let's go back. Sometimes my finger gets a little very happy on the clicking. Okay, so here we go. Back to our functions. And I have my add to queue and integration. And so we are looking at the inputs and how we can pick any input at all that we want. Then we have the actual code and then outputs. Now you did see that it spit out a little string, right, in the output. So that shows up here as well. And that's just from the return statement in the function, because that still works. But I can also use this $return as the response parameter name as well. But I can also add, say, another output if I wanted to. Say I wanted to take this HTTP endpoint and accept that name and then just pop it on a queue, or even in blob storage or something else that I wanted to do, I could do that. So I could come here and maybe I'll pick Azure Queue Storage. And then I could pick my message parameter name. So I could leave it as maybe output queue item, and the queue name as, say, out queue is fine. I just have to remember these because these are what we're going to call them in code later. And I click OK. You'll see it starts to add it here in my outputs. Oh, there we go. And what I'll do is I'll go back to my code. And if I want to connect and spit out some output and connect to that queue, first I'll come here in my arguments list and I'll just squeeze in. The order doesn't matter. I don't know why I just like to squeeze them in. I just like to have the logger as the last one. So I'll squeeze in this output queue item, and I'll just have it of type iCollector of string. So that's the type that we would use for the queue. And then I can go ahead and just pop anything on the queue that I need to. So here, after I have this little bit of code that checks to see if there is or isn't a query string in the URL, then it decides what the name is going to be. Here, I'll just paste in a little bit of code that just pops that onto the queue. So it takes that output queue item and does a .add, just like any other collection. So you can see all the code in here is just plain old .NET code. There's nothing fancy or special about this. We're using a stream reader, JSON convert, standard operators. This is not weird new .NET code. It's standard code, but in this slightly modified environment, just to run a single function at a time. So I'll go ahead and save that. And usually it gives me a little log. So now that I have that, if I run it, I don't, oh, I do have a queue now because I did go to the integration. But I'm not going to know, I mean, it'll run, but I'm not necessarily going to know where it's going yet. So if I run this again, yes, this executes. Oh, great, I could see it here, it did it. As a matter of fact, you could come in here and click on logs at any time and it'll give you a nice little trace. This is great, but maybe I want to actually pick that piece of data up. So back in my function app, instead of just add to queue, maybe I will add a function to get from the queue. I'll do this again in the portal, but this time the trigger will be whenever something goes on Azure Queue Storage. So I'll click on Azure Queue Storage and I'll call it get from queue. So I have a get from queue and the queue name should be out queue because I believe that's what I used before. Yes, out queue. And my queue item, no, output queue item was the actual argument name in the first function. So, but this should be fine, out queue for the queue name. And click add and give it a second. And it should show up in here. There we go. Okay, it takes us right to that function. So now I have some information about it. And if I go to code plus test here, this is much smaller, so you can see, oh, so whenever something gets popped on a queue, it passes that queue item in as a string, and of course you get the logger, and here we're just spitting out in the log that queue information. So I'll bring up the logs, it says that we're connected, and then I will go ahead and refresh this page again, and we'll see what happens. And it does, it looks like it did process it, and it did actually pick up that item. So that ran the HTTP function, and then that popped Joe, the name passed right over to here through those bindings. So we had the input trigger, the trigger, and the input from the HTTP request, and then we ran the code, and then it passed that piece of data to a binding, and the binding was the Azure queue. And then a second function to take the queue and just pick up items as they come onto the queue, just pick them off of the queue. So from here, I could do whatever I need to do with this item. And it's not just queues and HTTP, but I could start off with a timer, or again, HTTP, maybe to blob storage or Cosmos DB, or like whatever else you need that's in Azure that you can connect to. And if you don't see it in these bindings in here, go check those extensions, right? And see here for the get from queue, the trigger is the queue storage, no other inputs, just the trigger, which is giving me an input as well. My code, which is that single line of code. And at this point, I don't have any outputs, but I could actually process this piece of data and send it somewhere else. So that's how you pass data as well from one function to another, is through these bindings, which is really nice and smooth. So then I can have multiple functions that send data to multiple locations in Azure at once. So that's really cool. So now that I have these, I'll really quickly go back to the function app. And I keep accidentally clicking on stuff. I'll go back to my function app, and way down here at the bottom, towards the bottom, those development tools, there's this little console here. This is great if you like working at the command line. So you can do all of your Azure command line stuff here, but you can also go to the app service editor. If I click on go, and I did it to open a nice new window because it's a little bit different of a UI. Takes it a minute, and I'll wait until it comes up. But you also get these advanced tools as well, which just takes you also to that editor. And again, the extensions. Just remember, whenever you want extensions, there's tons of them for you to choose. And you can actually even upload your own. You can upload your own custom DLLs. So if you already had business logic in a DLL, you can upload them and reference them out of your Azure functions as well. But as you see here, dynamics, And of course, you might integrate with Microsoft Dynamics and lots of other good stuff. Here's that app service editor. Suspiciously looks a lot like VS Code, but here I could actually, it's a little bit nicer of an editor over on this part of it than over in the regular one. And you'll notice here, the extensions, when it actually does it, if you use Writer or a tool, you'll have .cs files for C#. It actually creates a CSX file. Right? And that's just so that it can adjust it to the Azure Functions runtime, because it is .NET, but with these little twists to make it work in the cloud. You'll also notice the JSON as well. This shows you can actually write all this yourself in a .json file and upload it. Right? So you can do your, here's your bindings, my HTTP trigger, right, my return, and my output queue for my add to queue. You can get to this JSON as well back in your function app. If I go to the app files, there should be a little drop down here where I can see those. Right, so I can see host in this case. And if I click on functions and I go to my code, there should be a little drop down in here as well for the other settings. Right, so I get my JSON.function and the host at the function root, and of course your little README. Now to match that up with what you would see in your editor or IDE here in Writer, and basically in any of them if they have a UI for this, you see I could do an add, and I can add an HTTP trigger. Right, and I could call it something like my whole trigger, whatever I want to call it. And then here, Writer actually fills out that same stub of code and even starts to ask, like, well, how do you want to do the, anonymous or function level auth? And you'll notice if you didn't pick stuff out of the portal UI, it shows up here as an attribute, right, which you'll see in the code when you go to upload this. So this is almost the same code. It's just that you get a little bit extra of attributes in here as well. And you'll see code like the usings and the namespace and the class that you don't see in the function code, right? You see, all I see is this async function called run. And I do see some usings in here, but hey, we're missing a class. They're not, they're putting it in for you. That's what the functions runtime is doing. But you see it when you're in the editor. So I can add any of those triggers. I can write the exact same code here. And, if you have a nice IDE like Writer, has a lot of tool tips and help and actions and intentions. And we even have the little cool, running and debugging right out of the editor and all this cool stuff. Also, you can change your local settings. So you can use local storage and debug it locally, which is very handy. Otherwise, debugging is not exactly the best online, right? Because that is an online editor. It's a little bit better in the app service editor, but it's not much. So you might want something local, right, for your debugging. And here's my host JSON, and I could add my function.json as well and add other settings as I need. And I can add one or more, as many functions as I need into my function app. When I'm ready, I can publish, and I could say I want to publish to Azure, of course. And then in here, it should go through, I might have to refresh and give me a list of existing apps if I want to publish this into an app that's out there already. But in my case, I started a whole new one here. So I would do something like creating a new app, and I would give it a whole new name. And you see, because of the uniqueness, they kind of date stamp it a little bit. And they just generate a nice little, what should be a unique number. And then you could pick your subscriptions, your resource groups, hosting plans, all of the stuff that you picked in the portal, you could choose here, or you could pick use existing. You can also pick a database connection if you are using any of the databases that are supported on Azure. So I could come here, storage account, like everything that you've seen exactly the same is available in here. And I did not pick out an app service plan somewhere. Resource group app name. There we go. Okay. And then you just click run. And as usual, it takes way longer. If it's more than a whole second, it's way longer than it ever should be, and computers are always like that. But it still does the same thing. Oh, in this case, I picked the a really bad tier. But if you go through, we'll actually just publish it online. And let me go and click really quick, just check what that does not like one of these tier. Oh, yeah, that should actually be fine. It's a little weird. Oh, location though. I think that might actually be kind of it. Let's do France. Storage account. Oh, of course it does. I'll just see if it will go ahead and try to run something here. But all this does is it takes all of these assets, packages them up in a zip, and then uploads them to Azure. And then you have the exact same thing that I showed you in the portal. So it's nice that you have these options. You could come in here and use your development tools, and you could get all of the help from a development tool that you would normally get with .NET coding. But then you can also deploy up to existing or new Azure Function app. One thing you will notice if you do, this would have bombed already if I had picked out the wrong one again. So it looks good. It just might take a little bit as it does. One thing you will notice though, if I start with the development tools, and this should not stop you from using development tools whatsoever. I think they're much better to do, but you don't necessarily get to see all of the management and maintenance stuff that you do in the portal with them. You can do some management of them in your IDE, but not quite all of it. But what'll happen is if I create the functions locally and then I upload them, then I will get a little message up here that says, oh, you've created them in the editor, you have to edit them in the editor. Okay, so there it's creating the zip, publishing the zip, or trying to publish the zip. So it's just taking a minute, and then we should see something in a bit. But you will get a little message here. The same thing if you publish just through the portal, and then you take that and connect to it with your IDE. The same thing. Once you get the IDE involved, it does not synchronize, at least at this time. And I'm not really sure what Microsoft's plans are, if they actually plan on doing something like that, synchronizing it, but it'll tell you you can only code it in one place. It's either going to be in the portal or in your tool. Should be perfectly fine for you to do. Should not stop you from using the tools. So let's take a look, see if this refreshed, if I see another, here we go. So here's another function app. This looks like it because I did not change any of the naming on this. Left it all default. And eventually in here, I should actually see the function. Oh, there it goes. My cool trigger. And if I come over to code and test, then I should be able to see some stuff, but not really change it. Yeah, so all I get is function JSON. If I try to do anything more with it, it's going to yell at me and tell me that I can't. So you can only get to some parts of it. But you still actually get to see at least the map and things like that from it. But you might get a message otherwise. It might take it a minute to refresh it a bit too. But you see, it doesn't even give you the option sometimes to see the CSX and go in there and change it. But it's still in there, right? And it works just the same. So this pretty much should be able to get you started with Azure Functions. The big takeaways are these nice use cases. Instead of just your standard Visual Studio projects, it would be, those little utilities, integrations, gluey bits of code, stuff like that, stuff that's really complex or really simple, things that fall outside of the scope of your standard issue file new project in Visual Studio, or your standard traditional application architecture like an N-tier or something. So things like that, so it's really good for, I mean, you can do those standard project types and functions too, that's fine, but they really shine on these these other bits, the integration, parts like that. And of course, they're running in the cloud, so they're always up and connected, and it's much easier to manage than trying to deploy in-house something that integrates very often. I find it much easier to manage it in Azure. Just don't forget, functions take that consumption plan, so they only cost you when they're running, and so you don't have run into any problems there. And it's basically all .NET code, and you're connecting these resources and passing data between them with just plain old .NET code, which really makes them very simple yet powerful, and I really like that about them. So that's basically all I have, and I guess I could stop the share and give back to the hosts now.
Yeah, we have some questions. Bogdan will share the screen.
Yeah, just a moment.
Thank you, Rachel, for the presentation. It was 0 to 100% in 1 hour with Azure Functions.
There's like so much to cover, and I have to cram it all in there.
Can you all see my screen?
Yeah.
Okay,
yes.
Perfect.
So it depends on the function. So maybe I'm anticipating, but how do I secure? So it depends on the function. You can do tokens. Security is built in. So there was the authentication and authorization tabs when you go into a function app and individual functions. So you could go in there and set up any of the security stuff that you need. And as well, when you do the HTTP triggers, you also can set up the, by the function to set in an API key or something like that as well. So it's all in there. I just did not have time in the hour to cover security as well. So, but definitely you can do it, and tokens is one way. So, and don't forget, it's all .NET. So anything that is a viable .NET security solution is very likely to work in Azure Functions. Yeah, so it depends. I suppose somebody could send bogus tokens and just try to tie up your resources, which would actually cost you money if it was not in the cloud as well. But at least if stuff is not necessarily going to be able to run, or you're like, security is going to stop stuff at the door before functions can run. So if it's secured that way, then you shouldn't have too much of a call, like each call costing you, because it's only when the code is running. Right, so if you can't start the call because it can't get past security, you should be okay. But if you say you don't have stuff secure and you just have an open endpoint, for an API or something like that, people could just keep calling and calling and trying to cost you money. But I haven't heard of anybody doing that. Not to say somebody wouldn't, though, because people are meanies sometimes. So, but yeah, any processing would cost.
So next question.
Yeah, so there are differences in cold starts between C# and other languages because the start times in those various platforms differs, right? The underlying code of the framework is different. It runs at different times, and takes longer or lesser to start up. I don't know if that affects pricing. I don't think so, but I can't say 100% for sure. So about that, I can look that up and come up with something. If you send me a DM on Twitter or something, or an email, I can look that up and find out. Yeah, sure. That's an easy one. Group them logically. That makes sense. And yep, that's the good practice, is just group your functions logically inside of an app that makes sense. But yes, you definitely don't necessarily have to have one per app. Multiple ones are fine. Nope, not yet. That one's an easy one.
And we also have questions in the chat. I'm not able to copy them for whatever reason. So we get this from Claudio. Just a sec. What is the typical startup time after not used for a long time? Does it has a cold start like web apps?
Yeah, you can have a cold start. I actually don't have a typical time listed as a cold start because that would actually depend on the language and other factors. But yes, you can have cold starts on them.
And another question, are there any memory usage limits, like when used for generating large documents?
Generally, no. You can generate a huge document and throw it, say, in blob storage. So the only limits would have to be the hardware and the actual resources. And that theoretically is supposed to be limitless, right? Because we're supposed to be able to put whatever we need to in there. So that shouldn't be a problem. It may cost you more just because of processing time. And if you're storing stuff, say in blob storage or other storages may cost, but that should not be a problem.
And another one, is there any advantage of Dockerized AF versus code only?
Maybe. So I'm not a big Docker person, like a big container, not Docker specifically, but just containers in general. So if you talk to somebody who is, I'm pretty sure they're going to tell you, yes, do the Docker thing. Containers are the best thing in the world. And I could see some uses for them, but I could also see where they might not be necessary. So I'm not sure I am the best person to ask for that, just because I don't really get into containers quite a bit, other than just, pulling down one once in a while to use it for development, stuff like that.
We should make a club.
Yeah, I feel like I'm the only person left who's not on the Docker Kubernetes train, doing the cha-cha there. But no, I haven't. But I also admitted I like FTP, so I'm old and cranky. I guess that's just how it is.
And there is a last question. Where do they fit into a DDD architecture? Let's say clean onion layered architecture.
So I guess that depends on like how much DDD you're doing. So if you can go to like a full microservice purist architecture with Azure Functions and serverless computing, and that there's a lot of resources on like DDD and fitting those in and doing all of the design principles to architect that. But then also you have a lot of hybrid solutions as well. Like I mentioned, you might pull out just parts of your system. But I believe DDD even covers that a little bit as well, where you could still use like DDD principles with those kind of solutions, as well as like non-microservice solutions, right? Your standard architectures. So it shouldn't be a problem to fit them in. It is .NET code. And the fact that it's just .NET code in the cloud that happens to have these connection points, it should still fit into DDD and basically any of your standard architecture, standard domain modeling, or any kind of systems modeling that you're doing. So it shouldn't really be a problem there.
Another one, is horizontal scaling possible?
I believe it is. When you say horizontal scaling, what do you exactly mean by that? So I think sometimes people think different things when they say that.
Yeah, I would assume, but we'll just ask Victor.
Just like more resources,
instances.
Okay. So yes, that
Okay,
you can do. Actually, scaling can automatically happen, but you can just go into Azure for any kind of Azure service, and you can actually tell it to scale at certain points. But for stuff like functions, it can automatically scale for you. But you can also do very fancy stuff, like very specifically splitting it across different data centers and stuff like that. You could get into some very advanced Azure architectures that way. that would be more like just in Azure in general, which applies to Azure Functions too, but like any resource in Azure, you should be able to scale like that, right? To be able to just add more machines, more resources, more compute time, or pick out different service levels that you need as you need them, or tell it to automatically figure it out for you.
Any other questions? Yes, we do. So another one from Claudio. When trying to leverage costs, are there any alternatives? Docker, can we see for a specific scenario which one is more appropriate? So basically, I think he's asking which is more specific, which scenario is specific to one scenario or the other one.
Like what's cheaper, Docker or not Docker?
Yeah.
I don't think, as far as I know, there's no documentation on a comparison of those two. I mean, there may be, but I've never looked for it. And I don't really think.
Docker versus web app versus Azure Functions. I think we can start a debate.
Well, web app versus Azure Functions are two different things, although you do have some of the same pricing models. But once you put it in a container, I'm not sure if that's going to give any pricing differences. I mean, in theory, if it's an Azure function and you're on the compute model, it's only while the code is executing. And having it in Docker should not make a difference. Like the execution time, right, should not really make a difference if it's in Docker versus not. Or I'm pretty sure it shouldn't, but a Docker expert might be able to say differently about that. But considering if that's the case, then it shouldn't be. But if you have something like one of the other models that you can pick up, the other pricing schemes, like one of the app service plans, that is not the consumption plan, that could be different, right? And that's going to be different just based off the fact that you have like a flat rate that could go over and stuff like that. That actually should be functions with Docker and functions without. Like if you compare those with that model, they should be the same as if you compare those with Docker and without in the compute model. You know, those should be the same. But other than that, I don't think Docker should make a huge difference. That might also be something for a Docker person, though.
Claudio is saying that online cost evaluation tools are not helping with choosing. Well, I think that's intentional.
There are the tools. I can't say that they always help with everything.
Yeah. So I think that's all. Thank you, Rachel, for being with us tonight. A lot of information and a lot of questions. And till next time, I guess.
Yeah, don't forget we have. Thank you, Rachel. Yeah. Don't forget we have 4 more meetups and 4 workshops at the end of the week. So we hope to see you there as well.
Yep.
Okay. I think that's all. Thank you, Rachel, again. And see you all tomorrow.